Okay, on to question number 3. So this one gives us a stack output in the debugger, some C code, and some assembly code to go with it. So we're going to go one question at a time here as we get to all of those. So first up is given the value of EBP is BFFF810 and ESP is BFFF7FO, what is the size of the stack frame? So we know that the stack frame is between EBP up to ESP, right? That's how big the stack is. And so to calculate this, we're just going to subtract the, smaller one from the larger one. And so EBP is going to be the larger one. So BFFF810 minus OXBFFF7FO. And we're doing hexadecimal math. That's the one really important thing we have to keep in mind here. So 0 minus 0 is still 0. 1 minus F, well, that's 1 minus 15. We can't do that, right? So we need to borrow from the digit to the left. And so we're going to make that 7 now. And we're going to carry the 1. And it's really important here that we remember that carrying the 1 is actually carrying a 16, right? So this is OX11 minus F is what we're doing in hex, right? And so this is 17, because 16 plus 1 minus 15 is going to give us 2 remaining. And so that's what we have left, 0, 2, 0, because the 7 minus 7 cancels out, BFFF cancels out, and so we have OX20 in hex. And again, important to sort of note here that that's a hexadecimal value, right? And generally, we're not going to tell someone like the size of the stack is OX20 bytes, right? They're going to want to know in decimal what that value is. So OX20 to decimal is the 16th place, so 2 times 16 is 32 bytes. Okay. So again, just hex math to find the value between the size between EBP and ESP, and then convert to decimal so that we can tell someone naturally what the size of the stack is. Part B, fill in the debugger command to display the entire stack frame below. So our blanks here are number of things. This is the format, and this is bytes or words are what we're going to fill in. So there's a great reference for all of the options for format in the notes. Recommend having that on your cheat sheet for the exam. So number of things, we want to print the entire stack frame. So we're probably going to default to 32. We're going to print it as hex because it's not telling us an explicit way to show this, right? And we're going to say bytes. So 32 XB. We could also divide 32 by 4 and do 8XW to get words instead, and that would also suffice. A bunch of different ways that we could do this. Here, we're going to use ESP because we're going to print starting from ESP down 32 bytes, and that'll show us the entire stack frame. So this is the address from which we're printing everything. On to part C, fill in the 3 missing blanks in the assembly language code. So here we need to look up and see what is missing from our code. And we can see we've got move dword PTR, EBP blank, OX735, move dword pointer, EBT blank, OX7A, etc. So we need to figure out what are those values in hex and how do they correspond to our code on the right. And it turns out that if we, you should just do this on your calculator, convert those values to hex or from hexadecimal, and that should just be that we have USNA. Or let's do it quickly here. OX735 in decimal is 1845. OX70A in decimal is 1802. And then OX7A2 in decimal should be our remaining value that we can see there is 1954. So that should be, at this point you play detective a little bit and you can see that we've got 1845 here in the code for USNA, 1802 for West Point, and 1954 for Air Force. So it's giving you an indication that these move statements are related to those values in our code. Here we want to think about what our stack looks like, right? So we've got EBP points to garbage, and then if we build our stack from bottom up as we read top down in our program, we're going to have USNA first on the stack, and then West Point, and then Air Force, right? And so this is what our stack should look like in memory. Each of these is an int that we have here. And you've seen this a lot in the code that we've looked at in examples, that we're going to show basically EBP minus some decimal value to get to this. So if we're trying to get from EBP to USNA, that's EBP minus 4. To get to West Point, that's going to be EBP minus 8. And then to get to Air Force, that's going to be EBP minus 12, right? So 4 bytes each time for the size of an int, right? We have all of these are ints in our program. So those are the context clues you need here. And then we're just matching up EBP minus 4, minus 8, and minus 12 with 1845 is USNA. You know, this one is 1802, so West Point, and this is Air Force, so 1954. Okay, so that's it for those 3 blanks. It's again just kind of looking for these clues and then understanding what the stack looks like in general. So on to part D, the character array service is copied into the stack at address BFFF7F0. Fill in the 4 missing blanks on the stack for service. So it's saying it starts here, right? The first byte on a line is the same address as is shown on the left here. So that's the first byte, 7F0. And we know that strings sort of go in order. So this is going to be service at 0, service at 1, service at 2, and service at 3, right? So let's look at what service is. Up here it says SWO, S-W-O, right? All caps. And so we need to know the values of S, W, and O on the ASCII table. So I'm going to pull that up again. And we've got capital S is 53 here. So 53 is going to be capital S. Capital W is up here, 57, so OX57. And then capital O is right here, is OX4F. Okay, so those are our ASCII values. Now we're out of characters to put here, right? But we know that the end of a string is always a null. And so we have to add in that null for service at 3. On to the last part here, the variable age is placed on the stack at address BFFF800. Fill in the 1 missing blank in the C program. So we know that it's here, right, at that B3, right? So our value in memory is OX000000B3. We have to read this sort of reverse little endian, right? Because it's put in memory in little endian order. So this is the little part of the number, so on and so forth. So we'd read this sort of right to left when we have debugger output. So OO0000B3. All right, so that's our value that we have there. We'll want to use your calculator to convert OXB3 to decimal to find out what number is there. And that is, to decimal is 179 that we're looking at here. So that's what we've got in age currently. Now, if we look it up at the C code here, we see that we've got age equals something minus USNA, right? So we need to find that value that we've got here in memory. So if we look at what USNA is, it's 1845. And we're going to add that 179 to that value. So 1845 plus 179. That gets us 2024, and that must be what that value was subtracted from, because we have that it's 179 in memory. So 2024 minus USNA would get us to age of 179. So that's it for that question.